Hello, so this is a revision video for AP Chemistry 9.3, Gibbs free energy and thermodynamic favorability. Gibbs free energy change combines enthalpy, entropy, and temperature to predict whether a chemical or physical process is thermodynamically favored. Standard Gibbs free energy, delta G standard, represents the maximum amount of energy available to do work from a chemical or physical process at constant temperature and pressure. A negative delta G standard means the reaction or process is thermodynamically favored. It can proceed without an overall external input of energy. A positive standard Gibbs free energy change means the reaction or process isn't favored under standard conditions. A little note here about standard conditions. Gibbs free energy values measured under standard conditions are referred to as standard Gibbs free energy values, shown with a standard symbol. Standard conditions refer to pure substances being in their most stable form, referred to as standard state, and solutes at a concentration of 1 molar, gases at a pressure of 1 atmosphere, and a common reference temperature of 25 degrees Celsius, 298 Kelvin. There are two main ways to calculate standard Gibbs free energy change. The first is standard Gibbs free energy change equals sum of standard Gibbs free energy of formation of products minus the sum of standard Gibbs free energy change of formation of reactants. We can use standard tables for Gibbs free energy formation values and multiply each one by its stoichiometric coefficient, so molar ratios in the balanced equation. We can also calculate standard Gibbs free energy change from enthalpy and entropy change, where delta G standard is Gibbs free energy change, delta H standard is enthalpy change, T is temperature, and delta S standard is entropy change. Exam tip here, remember to check and convert units when using this equation. Entropy change delta S is usually given in joules per Kelvin per mole, whereas enthalpy change delta H and Gibbs free energy change delta G are usually given in kilojoules per mole, so you must convert delta S to kilojoules per mole per Kelvin by dividing it by 1000 before using this equation. The signs of delta H standard and delta S standard can be used to predict whether the reaction is thermodynamically favorable. If delta H standard is negative and delta S standard is positive, then delta G is always going to be negative at all temperatures, so the reaction will always be thermodynamically favorable. If, however, delta H standard is negative and delta S standard is negative, then now delta G will only be less than 0 at low temperatures, so the reaction or process is only thermodynamically favorable at low temperatures. If delta H standard is positive and delta S standard is positive, now delta G will only be less than 0 at high temperatures, meaning the reaction is only thermodynamically favorable at a high temperature. And finally, if delta H standard is positive and delta S standard is negative, then delta G will always be positive, regardless of the temperature, so the reaction or process is never thermodynamically favorable. Gibbs free energy change is really important because some processes can't be predicted by enthalpy change alone. Both the enthalpy and entropy change must be considered to determine if the process is thermodynamically favorable, and this is where Gibbs free energy change becomes so important. A process is considered to be thermodynamically favorable when delta G is negative. This means the process can occur without any overall external input of energy. Note that sometimes the words spontaneous and feasible are used to describe this as well.